Welcome back to IR Design Expert channel. Today we are discussing about the material handling device in part 2. The first part 1 is already available in description. Link is available in description, and the same time the part 2 is now to be animated one. This is for very innovative material handling system for the part 2. You can see this diagram. This is to be animated is also available. How to be animate this material handling systems, and just want to forklift, front of the forklift is also available. Just want moving up and down direction. Part 1 material handling system is already available in my YouTube channel. You can go and see there. First you can edit this previous one component. Just want to edit bottom portion. You can edit it, and you can give a reflection of increasing the length of the bottom plate. So just right click and select you can increasing this previous one is 100 mm. Now we can modify it 150 mm. Okay, delete this remaining things, and now we can go to the these things to be deleted now. So click and delete all, and the sketches also we can delete. Okay, and now going to create a rectangle at the center of the data plane. You can use that to create a rectangular. This rectangular side thickness is 7 mm. Bottom length is 15 mm. Create a center axis for the vertical columns. We select the center axis, draw the center of the component. Between you can picking the center of the previous rectangular. And just want to select the center axis. Create a vertical center axis, and both of them you can select and click the mid plane. Automatically mid needs to be fixed here. Going to exit sketch and extrude, and you can this to be mid plane. You can select the mid plane. The 5 mm thickness. You can increase the thickness around 7 mm. Okay, the same thing should be mirroring on use of the data plane. So the front data plane you can mirror it. These both of them you can mirror. Both of them mirror with use of the right data plane. Okay, again you have to select the data plane. Create a sketch. Click a line. Center line. The center line, mid of the center line, you can draw one circle. The circle diameter you can give it 15 mm. Same thing is to be mid plane, extrude and mid plane. This to be created. This to be edit. Right click and edit, and draw the center circle. Okay, this to be extruded. Going to mirror. So the front data plate, and these both of them you can select and then mirror in another one mirror. You can use that to mirror. Okay, it is completed. Now I'm going to give the color of these wheels. Black color. Okay, so we give it the color of the wheel. And the circular bed and the linear patterns should be the revolved surfaces or components should be you can modify now. So to drag it should be coming the bottom feature. Automatically now we can increasing the length of the component. Okay, so we increased. The reason is at the same place you can edit in the sense in between any suppressors available in the sense automatically suppress entire the component. So you can drag it in bottom feature. You can just edit it. And top surface you can select and sketch. Here the component it is you can also select as all the edges of soft top surfaces. Offset this direction with this direction. So we will also even extrude. 7 mm thickness you can extrude it. Now we can create a side surface. You can select and click a sketch button and just go to the wireframe model. You can select it and these surfaces you can make it for the one smaller pin. These pins to be connected for the connected use of the levers. So to select the bottom pin, the pin diameter should be 3 mm. Exit sketch, extrude. The thickness length is 5. Again going to edit for this pin, the in between distance. The bottom to top, bottom to center hole should be 4 mm. Okay, now it is completed. Again select a solid model. Again this is a mirror. Use of the right data plane. Mirror in opposite direction. Same time these two is to be mirroring with use of the front data plane. Here we can align that two levers. Two lifting levers can be aligned here only. Now we can increasing the length of this extrude is to be 20. Now this part is over. Now going to create a lever. New command and select a part. Okay. sketch and front data plane. Create a rectangular. This dimension length of the rectangular is provided here. This tab 300 and side thickness is to be provided for the 20 mm. Now we can extrude and then we can make it for radius. This thickness to be provided for 7 mm. Okay, now going to extrude thickness. Here we can provide it at 4 mm mid plane. You can click it for mid plane, maintain it to be half portion of 2 mm and remaining half portion of 2 mm, and then select the sketch and side surface of the pin. You can select it and then create out center axis by selecting the circle and draw the circle of the outside corner of the rectangular. Select the two corners. This will be 5 mm. Now I'm going to select the circle, and this circle diameter is 5. And then between distance is also 5. Here we can provide that the pin diameter. Pin diameter is here you can align that. So the pin diameter is 3 only. So now we can modify that 5. So automatically it should be modified in all the pins. Okay. Now I'm going to create this extrude cut. Select the sketch. Okay, and this extrude cut you can going to mirror use of the right data plane. I'm going to give a roundness. This is a fillet to be provided for all the corners. So without any accidents, we can easy to moving on the lever use of simply you can use that. This will be a pump. Okay. Thickness you can edit, right click and edit. This is 3 mm. We can save it. Lever, and again you can select a new part. And select a circle and draw the circle. The diameter is 5 mm. Extrude. Supporting pin. Supporting pin you can connect it with the two levers. Same time connecting with the top of the plate. Mid plane, the length is 100 mm thickness. Now it is also shaped. Shaft. Before that, going to select the top of the surface and select the data plane. Draw the data plane. 10 mm height, you can create a data plane. Here we can create this inner surface of the edges. Inner edges you can select. Convert entities. Select inner edges. Okay, it is created. Now we can thickness is 10 mm. Okay, it is created. Height the data plate. Data plate height is you can provide it up to the top of the entire component, so only should delete the remaining material. So click on the sketch and draw it a bigger rectangular. That's how to extrude cut. I'm going to select extrude cut, automatically the remaining materials will be removed, and then I'm going to select save as component. Save as. Okay, now going to the top of the plate you can create it. It's a very simplest method. Otherwise you can going to draw the rectangular and then same edits to be given. Now going to save as the same another name can be given automatically. The component should be saved, the new one. Now going to select the side surface. Can provide that pin holding holder you can create it. Just should create a circle and then select two edges to be connected with the top plate. And this is a 5 mm diameter. And remaining portions to be deleted. And the length is 5 mm. Another one circle is created. Now press this to be 7 mm. Make the circle is of 5 mm. Now the same dimensions will be provided for another one surfaces. We extrude now this sketch to be extruded. For the opposite side, I should flip it. 3 thickness is created. Mirror. Show the front data plate. Edit. Again, then we can select these two components features. You can select and then make it a mirror. This right data plate. This is created for top plate. Top plate you can create it on the assembly. First thing you can create the bottom chair. There is a 4 plates to be provided for here. Is to be created, and then levers, support levers is to be created. Just to copy paste since automatically created from components. First thing you can create that, and then another one that can shaft. Just to do shaft, you can use that. And top plate, and that's what you change the axis. Okay, there is only you can fix it in top direction. Mat, circle, this pin, and this is to be aligned that front surface. Front surface. Front surface. Dimensions and distance of the mat. This distance is to be provided at 6 mm. And the next lever, this is fixed in another one pin. same time this top surface to this top surface automatically should be aligned. It can be provided that dimension distance mat. This is for 6 mm. This is 6 mm, here the 0 mm. So only you can easy to align that without hitting up these levers. It's to be easy to move. So only we can provide that for 6 mm for one side, another one side is a 0 mm. Okay, here without hitting up the levers to be aligned here. And then copy mat. For this command, going to click arrow mark and select this pin and the front surface of the pin. Select the front surface. Okay, it is to be aligned. And okay, close it. Again copy with mat for the next lever. Clear. Click this component and click this concentric mat and then select the distance for the center pin. Okay, it's to be completed. And now we can mat with this shaft, this shafts are mat. Okay, and then we can mat the center of the component, and the shaft center plane we can use to mat it, or otherwise we can use to with mat. Advanced command with mat you can use. The same features are available, same operations you can available here. And next one, so to click it the concentric mat. At the same time another one circle is also. Here is also we can select right side full assemble mat, and then support shaft support front plane mat. The right plane can be deleted and select this component. So to unpick and then select this right plane, automatically should be aligned. Okay, now the shaft is aligned. Now going to again mat, you can select it the lever concentric mat you can use to select it, and you can select the shaft. And this side surface, next to mat you can front surface. Okay, so to change the flip direction, change this flip direction. Okay, and then going to mat it. Now just have to drag the material, drag the lever, how to be aligned it. Okay, and now going to fix it for the top plate. And another lever, this lever, the concentric mat you can fix it here. fixed here, and then okay, and again select this surface and this outer surface. Now we can distance mat, we can use that to distance mat for the distance for the 7 mm. So the flip direction can change it. Okay, it is to be completed. This also we can moving, so to moving of the direction of moving. Just click and drag automatically which are the positions should be fixed, remaining degrees of freedom should be aligned here, and then copy with mat and select the component, and just you click the arrow mark and select the circle which portion to be concentric mat you can paste here. Just so to select it, and again going to fringe side of the component. Okay, this to be aligned, and next one close it, and then again copy with mat, select the component and the concentric mat and this surface of the component. Okay, this is completed. Now so to drag and fix the location of these levers. Okay, now going to select a mat command for inner concentric and this concentric, these two circles to be fixed in the same location. Okay, and then these two circles. Okay, it's matted. Now we can fix it for this inner surface and this inner surface. Okay, it is matted, and again you can select it. Now we can mat it, and the component right plane, and the top surface, lifting of the plate, right plane, both of them can be matted. Okay, now it is completed. Again going to select this top component to mat with these levers. You can see there is to be aligned in particular location should be fixed here. Okay, this is 90% is to be completed. Just you to check it how what are the way of movement is possible. You can check this. Just drag it, automatically should be moving. provide the mechanism for moving the oscillation movement. You can use that to motion study analysis. They're going to give a frames, number of frames for 100, 1000. At the same time select top surface and give a linear motor for the downward direction, and then oscillating motion you can give it. This is what this blade should be moving top and down direction. You can give a 30 mm distance. Okay, now we can go into calculate. Before that, we can check it for the motion study or not. You can check it. Now we can moving. It should be oscillating excellent manner. It should be locating here and then upward direction. Okay, the material should be lifted with use of the front fork, and at the same time the top side of the lifting device you can use that. Okay, this is to be a very simplest way of mechanism. Now we can give a 100 mm. This to be easiest way, the faster movement of the frame times from frame is to be 100, and please be faster way of movement is also possible. This will be excellently moving in up and down direction. Center of the blade, it should be moving up and down direction. This to be oscillation, so we can use that picking of the linear motor, and automatically it should be elevated and oscillation. This material handling system is a mechanical engineer. You can use that. This other system is previous one. It's part 2. Now we can play. This to be excellently moving here. Fastest motor is also should be moving in very freely. To click create a video. It's to be rotated for rotary model, and click y-axis for rotary motion, and rotate per second is at 10. It is to be clockwise motion, and then select it. Now we can going to create this video. Time the playing should be automatically should be moving like that. Okay, now I'm going to create as a video or saved animation file. Let us go to click and then create it as a video file. You can generate it with rotary motion, and then oscillation motion is also. Okay, thank you for watching our Design Expert channel. This is our first part of material handling system. And go and see there. Please subscribe my channel. Thank you for watching.